All right, I know I did these in class. I'm going to go ahead and do them again with you so that you can watch it as many times as you need to. So we have, again, our given always. And the other one. Okay? And we're trying to prove that two parts are equal, and we really can't get there without proving congruent triangles. So we will do so. BD is a bisector of ABC, angle ABC. So in other words, this angle here is being cut in half, cut into two equal parts. So that's what it means. I'm going to go ahead and put a 1 and a 2 in here. So I can say angle 1 is equal to angle 2, not 4, 2. And it is the definition of bisect. Altitude. Altitude means perpendicular. So if this is the altitude of this triangle, that means that this is 90 degrees. So I'm going to put a 3 and a 4 in here so we can talk about this. Angle 3 is equal to angle 4, which is equal to 90. Whoops, I forgot to write given. Because of the definition of altitude. So I've got this going on. And I need something else to get my triangles are congruent, so I'm going to go ahead and do my reflexive. So I've got all of these bad boys of an angle, and a side, but specifically the side is in between the two angles. So that's what we've got going on. And I would say that triangle ABD is equal to triangle CBD, or congruent rather. And from there, I'm done. Why are these equal? We look at our picture. Our picture is saying it's because the congruent triangles, so we write that. Congruent triangles give us congruent parts. All right, next. Again, we write our given. Bisect means, like we talked about on the previous one, to cut in half. So if we are bisecting each other, what we mean by that is that these guys are going to be equal to each other, and those guys are going to be equal to each other. And both of those reasons are identical. It's just simply definition of bisect. I don't have any other information, so I have to look back at the picture and see if I can get anything else, and I hopefully recognize that these are vertical angles. I look back at my picture and I say, oh, I've got congruent triangles. Now that I have congruent triangles, I can take a step back and say, all right, that is lovely, but how is that going to be helpful? So I've got what, ABC and DEC, and our reason is SAS. Now, I want to show that they're parallel. The only way I can show that they're parallel is if I can show that the angles are equal to each other. So this angle and this angle are equal to each other because I just proved the whole triangles were congruent. So obviously the angles are equal to each other as well. So this is congruent. I look up here. This is why congruent triangles give me congruent parts. And then since I have those angles are equal to, that's why these little dudes are parallel. And these angles give me parallel, which means alternate, that's what these are, alternate interior angles are congruent, give me parallel